So on the diagram below, sketch and label the predicted path for the ball for angle 20 and 40. So if we use the same speed, if same launching speeds are there and all for angle 20 and 40, so basically what happened till 45, the range, like if I launch a projectile with an angle of 10, 20, 45, when it is 45, it will be maximum. When it is more than 45 but with the same speed, so what we observe, like at 45 it will have a maximum range. 10, because theta is smaller, so as theta is smaller, we are keeping the same by, because what happened, it is about the values. Here when we increase the launching angle, the height will also increase, remain in air for longer period of a time. At 45 it is maximum, but after 45 the range start to decrease. So they already mentioned the positions. At 20 it was 1 meter, and 40 it is 4.7 meter. So when it is launched at an angle of 20, it should be 1 meter. When it is launched at an angle of 40, it should be 4.8 meters. Is it clear, this part? Then page 28. Okay, in this question, they mention a skateboarder threw a ball vertically upward while traveling at a constant horizontal speed. The skateboarder catches the ball the moment um, it's still moving horizontally. Why the ball can be caught even though it is thrown vertically and the skateboarder is moving horizontally? Like example, a person is there on a skateboard, he's moving, he throw the ball upward, but because he's having the horizontal component, so when he try to throw the ball upward, the ball will have both horizontal and vertical. But what is the horizontal component? What is the horizontal component of the ball? The horizontal component of a ball is same as horizontal component of the skateboarder. Like example, if a skateboard is moving with 5 meter per second, the ball horizontally also move with 5 meter per second. But what about the vertical motion? Because vertical motion and horizontal motion are independent of each other. So vertically, first when it is going up, it will decelerate with a constant deceleration, and when it is coming down, it will accelerate. But what about horizontal component? The horizontal component throughout the motion will remain 5 meter per second, so the ball will always remain above his head, because the horizontal speed of the ball is same as horizontal speed of the skateboarder. So basically you will mention the horizontal speed of the ball is constant, as well as horizontal speed of the skateboarder. Both have the same horizontal speed. There is no air resistance, so there is no change in the horizontal speed. That is why a person will be able to catch this ball, or the ball will remain all the time, it will remain above him. Is it clear? So the horizontal speed of the ball is same as horizontal speed of the skateboarder. So both will cover the same distance, and there is no horizontal acceleration or change in speed. The ball, so that's why he's able to catch the ball. Or vertical motion is independent of horizontal motion. Is it clear, this part? This was page number 28. Is it clear? Then page 31. Question 24, B, 2, and C. Page 31, B, 2, and C. Show that the value given for initial velocity leads to a value of horizontal distance by the ball in agreement with stated value 200 yards or 183 meter. So basically what they mention here, the astronaut hit the ball with a golf club. He rode the ball, which would have gone 30 to 40 yards on Earth, went over 200 yards. The ball stayed up in a black sky for almost 30 seconds. Like this is the duration, the time. Assume initial velocity is 18 with an angle of 34. Basically, we need a range. So how to get the range? So the launching angle is 34. The launching angle, the launching angle with horizontal is 34. Launch with a speed of 18 meter per second. And this is the duration for which the ball remain in air. So what is the duration? It remain almost 30 seconds. So that's a time. But to get the range, this is the second part I'm discussing, not the A1, B1. This is B2. But because I need the values, that's why I was showing the question. So it remained for 30 seconds. So I need a horizontal speed to calculate a range. So horizontal speed will be 18 cos 34. So we know the horizontal speed, we know the time. So range will be equal to 18 cos 34 multiplied by 30. What is the answer for the range? When you multiply this, so 18 cos 34 multiplied by time for 447, the time interval show the time for the flight of 30 seconds is over twice the actual value. Okay, basically, look what happened. This is the suggestion by the astronaut. The astronaut suggested it is 30 seconds, but when you calculate the time interval in the previous part, it will come out, I guess, 12.4 seconds, the actual time. So we will take the actual time. We will not take the astronaut value. Astronaut suggested that the ball will remain for 30 seconds until cover, but the actual time is 12.4. That's why we have to take the actual time. So it will be 18 cos 34 multiplied by actual time, which is 12.4. So what is our answer? 18 cos 34 multiplied by 12.4. What's the answer? That's 185 meters. So that's equal to 1. So that's true because astronaut suggested it will cover around 200 yards and it is covering, like, went over 200 yards. So that's true because 183 meters equals to 200 yard and it is covering 185 meter, which is more than 200 yards. then a projectile would have a greater range on the moon than that of Earth because lower gravitational field strength and lack of atmosphere. How each of these factors would increase the range? Actually, it's the same thing. They asked like how air resistance and the vertical forces affects the range. So basically what happened, look, when you increase the time of the flight, the range automatically will increase. So if the acceleration due to gravity is smaller, so it will have less acceleration. And if it is having less acceleration, it will take more time. Like the time taken for the flight increases. As the time taken for the flight increases, so range will also increases. And second thing, how the air resistance effect. So air resistance, there is like or lack of atmosphere, so there is no force which oppose the motion. If the force is not opposing the motion, so there is no deceleration in the horizontal component. The horizontal component remains same throughout the motion. That's why it will have a maximum range or greater range. So both of these factors would increase the range. How gravity is affecting, if smaller gravity means the projectile will remain in air for a longer period of a time. As it remain in air for a longer period of a time, so it means the range will be higher. Same thing, the horizontal if there is no air resistance, so horizontal component is not will not decrease, it will remain constant. So as it remain constant or it will keep its one value, so we will get a maximum or higher range. Page 33. In reality, when athlete land, his center of the gravity is 50 centimeter lower than its position of the takeoff. Calculate the extra horizontal distance. So basically what happened, because like here the center of the mass or center of a gravity of athlete is there, but when he jumps and his center of the gravity is below the actual point of where he lands, so and what is the this extra height? It is 50 centimeter, 0.05, 0.5 meter or half meter. So what we have to do, we have to calculate this range, like extra distance. Now to calculate this extra distance, what is the launching speed? Look, he take off with a horizontal speed of 8. So he was having a horizontal speed of 8 meter per second. And his vertical speed is 2.8. So originally he's also having a vertical speed of 2.8. Horizontal speed does not change, remains same. Like all the position, I'm using a different color arrow so you can distinguish. The horizontal speed remains same throughout the motion. But the vertical speed, what happened? The vertical speed start to decrease. He decelerate at this point. There's no vertical speed, and then again start to increase, accelerate. So when he reached the same point where he, like when his center of the mass come back to the same position, so it means at that moment the vertical speed was 2.8. Here at this point also the vertical speed will be 2.8, because like if a projectile is going up, the initial speed was 2.8. It reaches a certain height and return back, the vertical speed will be 2.8, but negative sign will be there. Negative only shows that direction, but the value of the vertical speed will be 2.8. So what we will do, we will first find this, how much time it will take to cover this extra distance. So again, because there is an acceleration, as there is an acceleration, whenever there is an acceleration, we always use equation of the motion. So we have the formula 2as or we can also use S is equals to ut plus half at square. But this equation will be difficult because like I have to use a quadratic equation. It will make like difficult to solve. So a simple method, what I will do first, I'll find the final speed and then I will use acceleration formula to get the time. Because basically what I need to cover this 50 centimeter, extra 50 centimeter or 0.5 meter, I want the time. So if I know the time, what I will do, I will use the horizontal speed and I will get this range. So first, I know the initial speed, the initial vertical speed is 2.8. So I have the distance, I know acceleration is due to gravity, which is 9.8. So I'll find the final speed first, V. So I will use the equation of the motion, which is 2as is equals to v square minus u square. I can also use s is equals to ut plus half at square. But in that case, it will be difficult to solve because it will form a quadratic equation. So 2as is equals to v square minus u square. So 2, gravity is 9.8, the distance, extra distance 0.5, final speed square, initial speed is 2.8 square. This will move other side, 2 into 9.8 into 0.5 plus 2.8 square. What's the final answer after taking the square root? First take a square of 2.8, then multiply 0.5 into 2 into 9.8 and then take the square root. What's the final answer for the velocity? The final answer for the velocity? Don't forget to take the square root. So when you solve, this will be 4.2 meter per second. That's the final speed. But we don't need the speed. We want the time, because if we know the time, we can use the formula for range. So we have the formula, like we need a time. So how to get the time? Acceleration is v minus u over t. So time is equals to change in velocity divided by acceleration. The final velocity, it's 4.2, initial velocity is 2.8 and acceleration is due to gravity 9.8. So we'll get the time, that is equals to 0.14 seconds. Now we get the time. So we need this extra distance. What about the horizontal? This was a vertical speed. What was the horizontal speed? The horizontal speed is already given. The initial, he take off with the horizontal speed of 8. So we know the horizontal speed is 8 and we know this time interval is 0.14. So we'll get the extra range, the distance. When you are using a horizontal component, there is no acceleration. So speed is distance over time, or distance is speed multiplied by time. So speed was 8 multiplied by time is 0.14. So 8 multiplied by 0.14. What's the final answer? 8 into 0.14. That's equal to 1.12. So 1.12 meters is the final answer, or the extra distance which this athlete will cover. Is it clear? Then page 34. Question number 26A. A rocket is launched at a level of the ground, one end along of a long table, and landed to the other end. At the same level, the student measured the horizontal distance traveled by the rocket and the time of the flight. The rocket traveled 1.88 meter and the time of the flight is 0.88. show that the horizontal component of the initial velocity is about 2. So how we can get this? Basically, what we will do, we will find the launching speed. So first we will find the initial speed. So we have the formula speed is equals to the range is given. So speed is distance divided by time. Because the range actually depends on the horizontal component. The range is given 1.88 and the time interval it's 0.88. So when we use the formula, range is equals to basically u cos theta into t, or horizontal component multiplied by t. So horizontal component we need. So what is the horizontal component? Range is 1.88. We don't know the horizontal component, and time is 0.88. So it will be 1.88 divided by 0.88. What's the answer? 2.13. So the initial horizontal speed is 2.13 meter per second. Then show that the vertical component of the initial velocity is about 4. So how to get the vertical component of initial velocity? Look, this is the total time of the flight. The total time is 0.88. So what we will do, we will divide our question into two halves. So if 0.88 is the total time, so how much time it will take to reach the maximum height? So maximum height, it will take half of that total time, so it will be 0.44. And acceleration is due to gravity, basically deceleration will be there. And we need initial vertical. So we need the vertical component. As we know, like initial vertical component, we are representing by u, but the final vertical component at maximum height, it will be 0. So we will use this formula. V is equals to u plus at. V is the final vertical, which is 0. U is the initial vertical, which we don't know. Acceleration is due to gravity, minus 9.8, because it is decelerating. And the time is 0.44. This is multiple. So this is 0. U minus 9 into 0.44. What's the answer? 4.31. So this is 4.31 negative. Other side it will move. So it will be 4.31 meter per second. So the vertical component is 4.31 and the horizontal component was 2.14. In the next part, they ask calculate the initial velocity. So just you have to use the Pythagoras theorem now. Look, you have the horizontal velocity, that was 2.14. And you have the vertical velocity. The vertical velocity which we calculated, that was 4.3. But what we need the speed at which it is launched. U. The actual, like not the component, so this is the horizontal component, vertical. If I replace the vertical component at this side, so what it will become? It will become a right angle triangle. The horizontal component is 2.4, 2.14, sorry, and the vertical component is 4.3. So I need the initial this u basically. So it's a hypotenuse. So according to Pythagoras theorem, hypotenuse square is equals to base square plus perpendicular square. So you will square these two. And if you need u, that's square root of 2.14 plus 4.3 square. You will get the value of the u. And if we need the angle, 4.8. So u is equals to 4.8. That's this u is a launching speed. And if we need an angle, if I need angle with horizontal, so this one is a base and this one is perpendicular. So theta is equals to tan inverse perpendicular over base. So 4.3 divided by 2.1814, you will get the angle. Is it clear? Any other question from this exercise of the projectile? Is there any other question related to the projectiles? Question 1C and 2C. Question in 1C, why a toy balloon is hit quickly up at an angle and appear to follow a path similar to that described in a 15th century? Because practically what happened, practically the horizontal, there is the air resistance. So what happened, the air resistance oppose the motion. So as the air resistance opposing the motion, vertical component is already decreasing. But what happened, the air resistance is also there, which oppose the horizontal component. So as it opposes the horizontal component does not remain constant. The horizontal component start to decrease. And eventually what happened? The horizontal component will be zero. If horizontal component is zero, the moment when the horizontal component is zero, so only the gravity is acting, and that gravity or the force of the gravity will cause its downward motion. That's why it will follow a path or a trajectory which is shown in 15th century. Is it clear? Because practically the horizontal component is not constant. You have to just show a path to show a projectile motion. Predicted range is 27 meter, but it is found only 8 meter. The air resistance and friction of the machine are the possible. Without further calculation, explain another why a projectile does not go as far as it is predicted. So what happened? Because like the photograph showing a war wolf, so there is a transfer of the energy, and it also depends on the point where it is released. The projectile, like predicted range is 27 meter. Basically what happened, when it reached this vertical position, the projectile is launched. But maybe the projectile, it is not launched exactly vertical, slightly tilted. So if it is launched slightly tilted, what will happen to the range? The range will also decrease. So there are many reasons why the range will not be same as the predicted one. Any other question or a doubt related to this exercise of the projectile? Is it clear?